Hello, and welcome to my past paper question video on acids and bases. So we'll go through the question and we'll have a quick go, and then I'll go through the answers. Ammonium compounds such as ammonium sulfate, NH4 twice SO4 can be used as fertilizers. Write a balanced equation to show how much ammonium sulfate could be formed by the reaction between aqueous ammonia and sulfuric acid. Ammonium sulfate is an example of a salt formed when an acid is neutralized by a base. Explain what is meant by the term salt. Why is ammonia acting as a base in the neutralization? And what is the relative formula mass of NH4 twice SO4? Give your answer to 1 decimal place. So I'll give you about 5 minutes to answer the question, as it's 4 marks long, and off you go. Okay, we'll go through the answers now. So this is our product, NH4 twice SO4. So balancing this, we need 2 NH3s, so we get 6 hydrogens and another 2 hydrogens to get our 8 hydrogens on this side, and that's it. We only need 1 sulfate group and we're done. Just 2 NH3 on that side in order to balance the entire equation. So that's what is meant by the term salt. It's when a H plus ion from an acid has been replaced by a metal or an ammonium ion. So why is ammonia acting as a base in the neutralization? Because ammonia accepts protons. NH3 is a H plus acceptor. And the relative formula mass for NH4 twice SO4 is 132.1. So you times 14 by 2 and you add 8 hydrogen atoms plus 32.1 and 16 times 4 to get that number there. And the next question now. Calcium oxide reacts with water and nitric acid. State the formula of the calcium compound formed when the calcium oxide reacts with water and when it reacts with nitric acid. Okay, hopefully that didn't take too long. Since you know that nitric acid is HNO3 and therefore that must have a charge of 1 minus, you can use 2 nitrate groups in order to bond ionically with the calcium here. Since it's a metal ion and it forms a 2 plus ion. With this OH, the same thing occurs, instead it's with water, and you need 2 OH groups in order for it to ionically bond with the calcium. So for question 3 now, both calcium carbonate CaCO3 and calcium oxide CaO are white solids. Dilute hydrochloric acid HCl can be used to identify whether a sample of the white solid is CaCO3 or CaO. Write the equations including the state symbols for the reaction of HCl with CaCO3 and the reaction of HCl with CaO. So, also what observations of the reactions with hydrochloric acid would allow the identification of the white solid. So it'll give you 6 minutes to do the equation stuff. Okay, we'll write the equations now. CaCO3. Now it says including state symbols, so always put a bracket around your state symbols because I get told off for not putting brackets around my state symbols now, which is bonkers. You need to put them as a subscript, but by atrocious writing, I do understand where the person's coming from. CaCl2 aqueous plus CO2 gaseous plus H2O. It's just a liquid on its own, so we put brackets around that. And then for this one, CaO solid plus 2HCl aqueous all goes to CaCl2 aqueous plus H2 hydrogen gas, which is gaseous. So the two observations that you should write down is the calcium carbonate, a gas is given off. So just write gas given off, or you could put effervescence. Like that. Although spelling the word is quite a chore. So just write gas evolved or gas given off for this particular question. And for this one, solid dissolves. Gives you the marks. You could also write solid reacts. So question 4 and 5. You need to define an acid and write a balanced equation for the reaction of magnesium oxide or dilute hydrochloric acid. And question 5, we need to describe what you would actually observe with magnesium ribbon plus hydrochloric acid. And you need to write the balanced equation for the reaction. And go! Okay. So an acid is a H plus donor, and the balanced equation is MgO plus, which is it's also a solid. It's good to get your state symbols in. HCl aqueous, which goes to Mg Cl2, so 2 HCl's on this side, and that's an aqueous, plus H2O liquid there. And describe what you see in the reaction. I'm going to put gas given off, or you could also put solid dissolves. Not really much happening with this reaction. So if we have Mg solid plus HCl aqueous, which goes to MgCl2, 2 on HCl on this side, aqueous plus H2 gaseous. So that's the first questions 1 to 5 done, and now we'll move on to the back for questions 6 and 7. So to prepare the aqueous calcium chloride, the student adds the exact amount of calcium so that all the hydrochloric acid reacts. So they use 50 centimeters cubed of 2 moles per decimeter cubed hydrochloric acid. So first step is to write a balanced equation, then how many moles of HCl is used, and then you have to calculate the mass of calcium that's used. So off we go again. We have Ca solid plus 2HCl, which goes to CaCl2 aqueous plus H2 gas. That's aqueous as well. Brackets, 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 brackets. And so, the moles is 2 times 50 over 1000. That's equal to 0.10 moles. And then, now using the molar ratio serious part now, 0.1 moles over 2, because we need the moles of calcium. Oh, sorry, mass of calcium. Yes, we also need the moles of calcium, but I'm focusing on the moles first, times 40.1, which is the molecular mass of calcium. And doing this gives us the mass of 2.005 grams. So that's 5 marks if you did all that correctly. For this particular one, calcium and its compounds have properties typical of group 2 in the periodic table. Calcium carbonate reacts with acids and nitric acid, and the equation is CaCO3 plus 2HNO3 equals Ca calcium nitrate, carbon dioxide, and H2O. So if we have 30.5% of H2O by mass, then it's safe to say that we can work out the mass moles of water first, which is 18 is our molecular mass. So 1 plus 1 plus 16 is 18, so then we get 1.694 moles for that. And then if we take 100 minus 30.5, we get 69.5%. Anhydrous compound, calcium nitrate, CaNO3 twice. And then we put 69.5 all over the molecular mass of calcium nitrate, which is 164.1, and that gives us 0.4235 ... moles. So now, putting 1.694 all over 0.42352 ... use the full calculator's display, or otherwise you might get a very odd number, which is not the answer, and then you will kick yourself over and over for not getting the number. If you get this far, then you are the master. So therefore X is 4. We have 4 H2O molecules for every hydrated calcium nitrate molecule. So that's it for these particular past paper question sets. I hope you found these useful. I have the questions in the description below if you want to have a go at them again. We'll put them out as a nice PDF to impress your friends with your chemistry skills. Thank you, and